In this video, we're going to talk about conditional probability. So, let's consider throwing two fair dice. What is the probability of getting a sum of 7 when it is given that the digit in the first die is greater than that of the second? Now, previously, we have just gotten probabilities without certain conditions, without certain situations that we need to consider first. However, in a lot of cases, there are probabilities that we need to consider provided something has happened first or provided there is a condition. Like this one, we want to get the probability of getting a sum of 7. However, there is a condition. That condition is that the digit in the first die is greater than that of the second die. So how do we now analyze this? First, of course, let's get the sample space of our experiment. So when we roll two fair die, probably we already know the results of throwing two fair dice. Rather, let's get how many possible results we get when we throw two fair dice. So what we would like to get would be the cardinality of our sample space S. So when you throw the first die, you get 6 possible results, and when you throw the second die, you get another 6 results. So by the fundamental principle of counting, you have 36 possible results. And we can express those results in a table. So we can have from your first die, 1, 2, 3, 4, 5, 6. Match it with your second die, 1, 2, 3, 4, 5, 6. So your first row can be 1, 1, can be 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. We can use or we can go back to this illustration later. Now, we want to get the probability of a sum of 7. So let's get those who have a sum of 7. That would be, of course, 1, 6. We would also have 2, 5. Then we would also have 3, 4. 4, 3. 5, 2. And then 6, 1. So there you go. So we now have our possible outcomes for the event that we want in which we get the sum of 7. Now, let's look at the condition. The condition is the digit in the first die is greater than the digit of the second. So that would mean we just need to consider those who fit in this condition. Now, since we know that it is given, so we can say that this event actually happened. So, let's take a peek into that. What is the probability, or not probability, but what are the possible outcomes when you have a digit in the first die is greater than the digit in the second die? So that would be, of course, 1 cannot be because no number here is greater than the others. For 2, it's only possible because 2 is greater than 1. But 2 onwards cannot be. For 3, 3 is greater than 1. 3 is greater than 2. 3 is not greater than 3, 4, 5, 6. So it's not part of this condition. 4 is greater than 1. 4 is greater than 2. 4 is greater than 3. Let me box out instead of encircle so we can see that they're actually part of the two events that we're looking into. 5 is greater than 1, 5 is greater than 2, greater than 3, greater than 4, and 6 is greater than 1, greater than 2, greater than 3, greater than 4, greater than 5. So we can see in our illustration that given that the green already happened, which is the first die or the digit in the first die is greater than the digit in the second die, those in green, given this has happened, we actually have 3 events or 3 outcomes rather that would fit that sum of 7, which is this one. Let's take a look into that. Let's have a different color. This one is actually 4, 3. 4, 3. Then this one, which is actually 5, 2. And this one, which is actually 6 and 1. So we have a total of three possible outcomes rather, that will get a sum of 7 provided the first die is greater than the second one. So that would mean that these are the possible outcomes. Now, since we already know that the event in green happened first, our sample space is not anymore all the 36, but only those in green, because that's the one that happened first, or that is the condition of our situation. So that would mean that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the sample space, or the cardinality of this set rather, would be 15. That would mean that out of the 15, first die is greater than the second, we have 3 possible outcomes that we get a sum of 7. In other words, the probability now, let's use the color purple here, the probability of getting a sum of 7, given that vertical line there is usually read as given that the digit in the first die is greater than the digit in the second die, is actually these 3 outcomes out of 15. Or in lowest terms, 1/5. Now, as you might have noticed, we did not use all 36, but only this 15, only those who were part of the condition. And this is our concept of conditional probability. This is the main thing in conditional probability, wherein our sample space becomes limited because of the condition that was given to us. We will not consider all anymore in the sample space because we have to consider the fact that something or a condition happened first.